This is section 10.3. This is the second video. We're going to look at theorem 10.4. If one chord is a perpendicular bisector of another, then the first chord is a diameter. So notice how we have these two chords, and we don't know for sure if either of them is a diameter. If one of them is a perpendicular bisector of the other, for example, segment SQ is going through the middle of chord TR, and it's at a right angle. We know it goes through the middle because of the markings. Then that means that that original chord, segment SQ, is a diameter, so it would have that center. That's what that means. Okay, now we also have another theorem. We're going to call this theorem 10.5. Let's say you do have a diameter, and it's perpendicular to a chord. Anytime that happens, it's going to bisect the chord and its arc. So if you know that a diameter crosses a chord, then that makes those the same, and it also makes these arcs the same. So it's going to make those segments of that chord congruent and the arcs congruent. Okay, so let's try an example. Let's use a diameter. Use the diagram of circle E to find the length of segment AC and tell what theorem you used. Well, this is circle E. That means point E is the center. That means segment BD is a diameter. We have a diameter that is perpendicular to a chord. Anytime that happens, you're going to use theorem 10.5 to say that this distance here is also 7. So that means the distance from A to C would have to be 14. Let's find the measure of the indicated arc in circle A. We want to find the measure of arc CD. So I'll make that arc green. I'll make this other arc blue because we'll probably have to reference it here in a second. Notice how we have a diameter and it's perpendicular to chord CE. That makes these two arcs congruent. We're going to solve for x. Looks like x is 8. Make sure you plug that in because we want to find the measure of the arc. 9 times 8 is 72. So that's what this is going to be too. 80 minus 8 is 72. What's the measure of arc DE? It's going to be the same thing. How about the measure of arc CE? Well, you're going to add those together. 72 and 72 gives you 144. Looks like we got one more theorem here. Theorem 10.6. In the same circle, or in congruent circles, two chords are congruent if and only if they are equidistant from the center. Now, remember how you're going to measure a distance from a line or a segment to a point. Remember, you have to measure on a right angle. That's important. These two chords, segment CD and segment AB, they have to be congruent if they're equidistant from the center. So if these segments are congruent, then the chords are congruent. And vice versa, because it's a biconditional. If the chords were congruent, then those distances from the center, they would be congruent too. Let's try an example. In this diagram, we have circle C. Segment QR, that's a chord, has the same length as segment ST, which is also a chord. They both have a length of 16. We want to find the distance from C to U. Okay, so here's what theorem 10.6 says. Your chords are congruent. That means the distance those chords are from the center have to be congruent. Now, obviously, you have to have right angles there. That's how you measure a distance from a point to a line. 5x minus 9 must be the same as 2x. X is 3. Plug that in. Looks like those distances are 6. Okay, now a little glimpse into the future here. This is a pretty basic problem. There's some other things you can do with this. It's kind of neat. What if I extended this segment into a diameter? See how the diameter is perpendicular to that chord? Doesn't that make those two pieces equal? 8 and 8. I'm going to draw you my favorite shape. It's a triangle. We knew this was 6 and this was 8. That means we can find the radius right now. The radius of the circle is 10. See how cool that is? Let's do one more. You got two chords. They are the same distance from the center. So if those are congruent, then that means that chord is also 32. How far is it from Q to R? We know that's 32. How about Q to U? Same as we did on that last slide. It's got to be 16, remember. This guy gets bisected because if we extend that guy into a diameter, it's perpendicular to that chord. What's the radius now? So let me use red here. Here's your right triangle. One side is 12, one side is 16. How long's the other side? So I got a 12, I got a 16, and I got something. This looks like a 3, 4, 5 to me. If I multiply 3, 4, 5 by 4, I get 12, 16, 20. So I'm going to say that radius is 20.